Hi everyone! In this video, I'll walk you through how energy is generated from glucose through three main processes: glycolysis, the formation of acetyl-CoA, and the citric acid cycle. We'll focus on the steps that generate ATP and the electron carriers, NADH and FADH2, which ultimately powers our cells. Glycolysis occurs in the cytoplasm and begins with one glucose molecule. The first ATP is used by hexokinase to convert glucose into glucose 6-phosphate. Another ATP is used by phosphofructokinase 1. Later, two ATP molecules are generated by phosphoglycerate kinase and another two by pyruvate kinase. Two NADH molecules are also generated and produced by glyceroldehyde 3-phosphate dehydrogenase. That's a net gain of 2 ATP and 2 NADH, or 5 ATP equivalents. Each pyruvate from glycolysis is transported into the mitochondria and converted into acetyl-CoA by pyruvate dehydrogenase. This step produces 1 NADH per pyruvate, or 2 NADH total per glucose molecule, equivalent to 5 ATP. The acetyl-CoA enters the citric acid cycle in the mitochondria. Key steps include the conversion of isocitrate to A-ketoglutarate, and then to succinyl-CoA, both generating NADH. Succinyl-CoA is converted to succinate, generating 2 ATP succinate, is then oxidized to fumarate, yielding 2 FADH2. Finally, malate is converted to oxyl acetate, forming another 2 NADH. This totals 6 NADH, 2 FADH2, and 2 ATP from one glucose, equivalent to 20 ATP. Now, let's sum up. Glycolysis gives us 2 ATP and 2 NADH, which converts to 7 ATP. Acetyl-CoA formation gives us 2 NADH, or 5 ATP. The citric acid cycle gives 6 NADH, 2 FADH2, and 2 ATP, equals to 20 ATP. That's 32 ATP total. But subtract 2 ATP is used during early glycolysis, and we get a net yield of 30 ATP per glucose. Overall, cellular respiration is an incredibly efficient process. From one glucose molecule, we can produce around 30 ATP thanks to the precise coordination of enzyme catalyzed reactions in glycolysis, the pyruvate transition step, and the citric acid cycle. The diagram shows the major steps of glycolysis. Note where ATP is used and produced and where NADH is generated. Glyceraldehyde 3-phosphate is a key intermediate in this pathway. Here we see the conversion of pyruvate into acetyl-CoA. This step bridges glycolysis and the citric acid cycle, and it's where the first carbon dioxide and pair of NADH are produced. The final diagram map the citric acid cycle. Each turn processes one acetyl-CoA, but since one glucose yields 2 acetyl-CoA, the full cycle spins twice, producing high-energy electron carriers used in oxidative phosphorylation.